three basic ways to look at the relationships within the ideal gas law: pressure versus temperature, pressure versus volume, and pressure versus number of particles. When a substance is in a gaseous state, its particles move freely to fill the whole volume of the container. Pressure is caused by collision of those particles with each other and the container. If you increase the temperature of these particles, you increase the velocity of those particles. Faster moving particles will have more collisions with each other and our container, meaning that pressure is proportional to temperature. If you decrease the volume of your container, your particles will have less free space and therefore collide more. This means that pressure is inversely proportional to volume. If you increase the number of particles in your volume, you would then have less space between particles, which means they will have more collisions in that space, making pressure proportional to the number of particles. Pressure, temperature, volume, and number of particles are the measurements that make up our relationship. However, at the moment, we can only talk about how these measurements relate to each other proportionally. We need to have some way to balance out all the units that go along with each of these measurements in order to use an equal sign. That is why we have the constant r and accompanying units. By placing r in our relationship, it allows us to cancel out all the other units that came with our measurements and leaves us with a proper equation, the ideal gas law equation, or as I called it in high school, PERV nerd.